Good day, students, and welcome to our online learning. Today we are going to continue with some work that we would have started last 2 weeks, which is matrices. So before I go into the objectives of the lesson, we will first have to go and revisit some of the things that we would have done before with matrices, and then we are going to do some multiple choice questions using matrices. So let's go back a bit and see what you would have learned from previous videos. Now, when we started the topic matrices, we identified a definition for matrices, and we said that a matrix is a system that is arranged using rows and columns. It's arranged in rows and columns. So it's a system that is made up of numbers, system of numbers, arranged in row by column form. All right? And when you look at the amount of rows inside of a matrix multiplied by the amount of columns, that is now going to give us what is called the order for the matrix. So the order speaks about the amount of rows multiplied by the amount of columns. Quite straightforward. Then we went and looked at some different types of matrix, and we added them and we subtracted them. And we also used the scalar. Now remember, when we were adding and subtracting matrices, when we did addition and the subtraction of matrices, what was important is that we have to have two matrices that are made up of the same number of rows and the same number of columns. So when we have, for example, a matrix A plus a matrix B, if A is the matrix with 1, 2, 4, 3, because it has 2 rows and 2 columns, then the matrix B must also have 2 rows and 2 columns for these two matrices to be able to add to each other. Let's say 4, 1, 6, and 3, for example. All right? And what I want us to remember is that when we added the components in this matrix A with what is in the matrix B, they must have the same row itinerary number and the same column itinerary number. So this item here, it's in the first row, all right? It's in the first row and it is in the first column. So this is very important. So this item, it is in the first row, first column. When I take this item to add with a member in the other matrix, it must also be from the first row and first column. So we have component matching with the other component that is like of its kind, right? And you can appreciate this 3 is in the second row, second column, and it will match with this 3, which is in the second row, second column. Remember, rows come first, then column after. When we finished looking at addition and subtraction, we looked at some special types of matrix. And one of them was the square matrix. The square matrix. And we said that this square matrix is the matrix that is comprised of the same number of rows and the same number of columns. And we basically focused only on the 2 by 2 square matrix. So this is an example of a 2 by 2 square matrix where we have 2 rows and 2 columns. All right? And what is special about a square matrix again is that let's use this matrix here. 1, 4, 2, and 3. What is special about this matrix is that it has 2 diagonals. This diagonal is called the leading diagonal, and the other diagonal, which is this one, is called the non-leading diagonal. And this is important again because let's just put the leading diagonal here. So for those of you who did not look at the videos, you can follow through with what is happening. So this is called our leading diagonal. All right? And this one is called our non-leading diagonal. Okay. Now, these square matrices now lend themselves nicely for us to be able to find what is called the inverse of a matrix. And that inverse is very important when it comes to dividing two matrices. All right? So we use the three-step formula. We had a three-step formula for finding the inverse of a matrix. Let's say this is our matrix A. I hope everybody is following, okay? So this is our matrix A. When we want to get the inverse of A, that we'll write as this one, A with the -1 at the power, -1 power at the top. We call this the inverse of A. So this is our inverse of A. And the three-step we used was first to find the determinant. So we are going to use shorthand, okay? And we said det of A. The determinant is basically taking the product for the members on the leading diagonal, and we're going to subtract both the product from the leading diagonal and the product of the non-leading diagonal. So we take the product for the leading diagonal, which would be 1 times 3, and we also take the product of the non-leading diagonal, which would be 2 times 4. All right? And we subtract them, and this is going to give us the determinant for the matrix. Let's just work it out so we have some form of proceeding. So this will give me 3 minus 2 times 4, which is 8. And this gives me 3 minus 8, which gives me -5. So the determinant of this matrix A is -5. We also now need to find remember we are trying to find the inverse, okay? Keep this in mind. So we also need to find now the adjoint of the matrix. Let's determine the adjoint. So the adjoint is ADJ of A. And this is quite simple. What we need to do for the adjoint, these members on the leading diagonal, you're going to swap them. And these members on the non-leading diagonal, we said that we will change their signs. So this is quite simple. Okay, so we swap, 3 goes up, 1 come down. And then we change the sign of the other two, -2, -4. Then the inverse now is equal to taking this adjoint and divided by the determinant. Very, very straightforward. So this is what we had. It's just that you can see what is happening here. All right? So this is what we had done last time. This is what we did last time when we look at the inverse. After we finished looking at the inverse, we looked at now solving simultaneous equations using matrices. So I'm going to give you a quick summary again of what we did with solving simultaneous equation using matrices. And quite simply, when we are solving a simultaneous equation using matrices, let's say, for example, 2x plus 4y equal to 7 and x minus y equal to 3. If we were to solve this, we said, first of all, you take the coefficients and you form the set of matrices